Hi, everybody. In this video, we're going to learn how to use Excel to create naive forecasting and also how to evaluating the quality of the forecasting result. And at the end, we're going to learn how can we develop the visualization to show the relationship between the actual and the forecast result. And so the data set we're using is coming from the University of Michigan Index of Consumer Sentiments. And so this index is range from 0 to 100. The larger the value, the better the consumer feeling about the economy. So the data we have is from January 2016 to December 2016. So our goal here is try to predict the value for January 2017. So the model we're using is called a naive forecasting model. So you can see on the screen that the model is expressed as a F, which is a future forecast value, and the T is the time period T, and that is equal to A is the actual observed value, and the subscription is the T minus 1, so that stands for the one period earlier than T, so that's T minus 1. So for instance, if T stands for 2024 and T minus 1 will be 2013. So for the naive forecast model, that's assume the last period's value will be equal to the next period's value. So this is very simple. That's why we call it naive forecasting. So now let's look at how can we use Excel to achieve this naive forecasting model result and measure the quality of the forecast, and also at the end to do some visualization. So as we mentioned about the value of next period is equal to the last period. So what we can see here is the data set, the actual value starting January 2016. So therefore, we are able to leverage the January 2016 value to predict the February 2016 value. So in the column C, that is where we're going to list our forecasting value. So that is equal to, on your Excel, you type in equal, and then you can just directly select the value from the B2. So that is the January 2016 actual value. And then after you select that, and you can push enter on your keyboard. So it's equal to 92. So obviously you can just type in the rest of the value, but for the Excel, we have very convenient drop down function. So what you need to do is select the column C and the C3 cell and move the mouse to the right down corner until the mouse change from to the dark cross, and then you left click the mouse and hold it, and then drag it down to the last cell. So now we finished our naive forecast. Okay, so this is our naive forecast. So next, we're going to look at how can we measure the quality of our forecasting result. So the metric we are using is called the mean absolute percent error. And so for this metric is calculated by looking for the difference between the actual value and the predicted value. So we also call it error. And then we are converted this value to the absolute value so that we know that at the end of the negative and the positive arrow will not cancel each other, so only the absolute value will be calculated. And then we will convert this absolute arrow to the percentage. So therefore we use divide by the actual value to get a percentage. And then after we getting on every observation's absolute percent error, we will use this summation form, means summation operation. We are summing all the absolute percent error together and then divided by the total sample size. Okay, so we are implement this formula to calculate the mean absolute percentage error for this case, and we are using Excel. So first, in the column D, we are calculating the error by finding the difference between the actual value and the forecast value. So you can see that we don't have any forecast value in the first row. The reason is because we don't need to forecast in January 2016 because that's the beginning of the data point. We only have actual value. And also, we don't need to find error for the last period, January 2017, because we don't actually have actual value. We only have the forecast value. So the only value we can use to calculate the mean absolute percentage is from February 2016 to December 2016. So let's do the identify the error first. So on our Excel, we type in equal sign, and then select the B3 cell, so that's the actual value for February 2016, and then minus the C3, so that is the forecast value for the February 2016. So after you achieve this result and then push enter on your keyboard, so you got negative zero point 0.3, and then we're gonna leverage the Excel's drop-down function to automatically fill in the rest of the observations cells. So we move the mouse to the right down corner, and then left click the mouse and hold it, and then drag it down to the cell D13, and then release the mouse. So you can see the Excel automatically calculate the error for every pair of the prediction and actual value. So now we are converting our error value to the absolute error, so that when we sum all the error together later, it will not cancel each other because the negative and the positive sign. So there is a formula in Excel allow you to calculate the absolute value. So in the E2 cell, you type in equal and the ABS. So this stands for absolute value. So ABS, and then parentheses, and then select the arrow you already calculated in column D. So the first arrow is in D3. So I select D3, and then I close the parentheses and then push enter. So now again, we're going to leverage the drop-down function from Excel to calculate the rest of the absolute error for us. So we select the cell which is calculated, and then move the mouse to the right down corner until it turns into a black cross. And then we left click the mouse and then hold it, and then drag it down to the E13 cell. So now you can see all the value in column E has turned into a positive sign. There's no negative sign anymore. So now, next step, we are converting our absolute error to percentage. So what we're gonna do is we are using every value we calculate in column E, divide by the corresponding value in column B. And then after we do that, we times 100, so we convert it to percentage. And then, so let's do it together. So in the column F, what we're gonna do is we type in equal, and then we use the value in column E, and then divided by the value in column B, and then times 100. So this is gonna converting the absolute value to absolute percent error, and then we push enter. So the first one, we got a 0.33, and then we use the Excel drop-down function. We select the F3, move the mouse to the right down corner until it turns into a black cross, and then we left click the mouse and then hold it, and then drag it down. So some people might ask why we want to convert the absolute error to the percentage error. So you have to understand that sometimes the model are have different measurement units for your predicted value. So for instance here, the University of Michigan Index of Consumer Sentiment. So the range is from 0 to 100. So how about if somebody convert to 0 to 1? So we try to compare the two model, which one is better? So without converting to the absolute percent error, you will obviously see the data that is forecasting range is 0 to 1 is doing better than a model forecasting range 0 to 100 because the measurement unit are different, so it's not comparable. And so in order to avoid that situation, allow you to compare the cross models. So we want to convert our absolute error to absolute percent error so that we can actually compare models. Okay, so after we calculating the absolute percent error for every period, what we need to do next is we need to sum all those errors, percentage error together, just like what we see in the equation, and then divide it by the total sample size n. Okay, so let's list our final value in our F15 cell. So we were using the Excel function called equal sum parentheses. So this allow us sum multiple value together. So we will select the value from F3 to F13. After you finish select, close the parentheses, and then we're going to divide by sample size n. So you definitely can't just count by yourself on in terms of how many observations we have here, but there's a more efficient way. Since we are using Excel, you can use the function called count. So this is going to give you the count of the observation you have in column F, and then parentheses, and we are selecting from same range from F3 to F13. And after you did that, close the parentheses and then push enter. Okay, 2.95. So that's our mean absolute percentage error. So for the mean percentage absolute error, you can see the idea is try to find difference between actual value and the forecasted value. So that means the smaller, the better. So basically, if A and F, your forecast equal to the actual value, so this MAPE actually going to equal to 0. But in the reality, any forecasting model, it will never ever get 0. And so but it just gives us a sense that the smaller the MAPE, the better of your forecasting results, right? So for this, for MAPE, there is no upper boundary, so it can be any positive. For the upper boundary, it's positive infinite. So for this result, 2.95, practically it kind of relatively small, but not ideal because this model is naive forecasting. And then in the future video, I will introduce a more sophisticated forecasting model. So you will be able to leverage those models to improve your measurement here. So it can reduce the 2.95. So it's an okay job, 2.95, given this is your first forecasting model. It's not doing that bad. Okay, so this is the second thing we learned in this video, how to calculate a measurement to measure the quality of your forecasting result. So the last part I want to teach in this video is that how can we create the visualization to show the relationship between the actual value and the forecasting value. So Excel have a very good function that is called the chart function. So first of all, what we try to do is we try to develop the line chart, having our actual value and forecasting value in the chart, and using our date to label our horizontal axis. So what we're going to do is, first of all, we are selecting column A and the column B's value. We left the last, column A to column C, all the value. So the reason we include column A is because we want to use those data to label our horizontal axis. So now, after you select value and click the Insert tab, okay, after you click the Insert tab, you will be able to see in the center, there is one section called the Chart. And then in this little icon, we will choose the Insert Line or Area Chart, and we are choosing the first one, okay? Great. So after we choose that one, you will notice that, wait a second, we're missing a line. We only have naive forecasting line. So we need to add in our actual line back, right? So in order to do that, we select the chart and you'll be able to see in the Excel, it automatically popped out a tab called the chart design. And then we're gonna, under the data section, we're gonna click the select data. So you can see after you do the select data, we only have one series that's naive forecasting result. So we're going to add in our column B's value into this series section. So what we're going to do is we're going to click add. So after you click add in the series name, you're going to click the series name, so which is the row of the column label for B. And then for the series value, you can click that little arrow and you will select the value from B2 to B13. So remember, we actually don't have it in B14, so we're going to leave it there. And then you click this arrow again. Oops. And then you can click OK. Sorry. Let's see. Okay, we'll click it. Great. So now you can see we have two lines now. However, now at this point, whoever read your chart have no clue why we have two lines. So what we're missing here is that we are missing our legend. So we need to add the legend so that the people can actually read the chart, right? So in order to add in the legend, you need to click the chart. And then again, the chart design tab will show up. On the left-hand side, you will be able to see add chart element. So you click add chart element and then move down, you will be able to see legend. So we can add in our legend to our chart. Okay, great. So some of you guys said, I really actually don't super like this final result. Um, because you want to choose different colors for you have different color of the line, but usually for the forecasting result we like use the data line. How can we change the line styles? So what you need to do is select your forecasting result line. So this is the blue line, and then uh, left double click the mouse. Okay, so you will have the format data point. So, okay, you actually need to select the whole line one more time. So you can see now all the dots on the line being selected. And then for the right hand side, you will be able to see format the data series and then go to the first tab. So this allow you to changing the filling and the lines. So now after you select that, on the bottom we have seen that the dash type. So then here by default is a solid line. So we can choose the dash line. So now, great. We convert our naive forecasting line to the dash line to indicating, okay, this is the forecasted result. So this is the end of this video. So in this video, to recap, what we learned is we learn how to do the naive forecasting using Excel. And then after that, we learn how to calculate the measurement that measure the forecasting result. That is a mean absolute percentage error. And after that, we learn how can we visualize our result by creating the line chart. Hope you are enjoying this video, and in the future video, I will talk about more other sophisticated forecasting model.